Alright, today we're going to talk about bisectors and triangles. First thing you need to know is concurrency of perpendicular bisectors. So, talking about triangles here. So let's get a triangle. And what the concurrency of perpendicular bisectors is the point where each perpendicular bisector meets in a given triangle. So this point right here, where those three perpendicular bisectors meet, is the point of concurrency. Now this point is the same distance from each one of the vertices. And what you can do is actually draw a circle around this triangle. I know that's not a very good circle, but pretend that's a circle. And that point of concurrency in the triangle would also be the center of your circle. And we call that the circumcenter. So the circumcenter is equal distance from each of the vertices. And if you drew a circle around the outside of the triangle, it would be the center of the circle. Alright, now we're going to find some circumcenters. I started with the right triangle because that's the easiest one to start with. So if we look at this line on the x-axis here, it's 4 units long. So the midpoint would be 2 units from either side. So it would be right here at 4, and we draw in a perpendicular line. Then you look at the side on the left, the vertical one, that's 6 units long, so the midpoint would be 3 units from either side. So at 3, you draw another line, and this point where they cross is the circumcenter. So our circumcenter for that red one would be at 4, 3. So let's look at a triangle that isn't a right triangle. Let's draw one in over here. Alright, so now we got a triangle that isn't a right triangle. And again, start with the lines that are either vertical or horizontal. Easiest to put in a vertical perpendicular bisector. And then you look at the other lines. So we'll look at this side right here. And that slope is going up 1, 2, 3, 4 over 1, 2. So my slope is 4 over 2, which equals 2 over 1. To find a perpendicular bisector, it has to equal negative 1. So we flip that and reverse it. So that would be negative 1/2 would be our slope. If you know the midpoint, which on this one we know this midpoint, it's right here. Because if we're going up 2 over 1, up 2 over 1 gets us the whole line. So if we only do it once, we know the midpoint. And then our slope is negative 1/2. So I'm going to go down 1 over 2. Well, if you look at this point right here, that's where they're going to meet. So that would be at negative 4, negative or positive 1.5. So negative 4, positive 1.5 would be our circumcenter. If we went from the other line, it would be the same thing. That slope is 2 over 1. Reverse that, it would be negative 1/2. So that would be down 1, right 2. So drawing that perpendicular bisector, again it goes through that same point of negative 4, 1.5. And just so we go over it, if it's a right triangle, the point of concurrency will always be on the triangle. So see how that line was on the triangle, or that point was on the triangle? It'll always be on. If it's an acute triangle, the point of concurrency will always be inside. If it's an obtuse triangle, the point of concurrency will always be outside the triangle. Alright, so now let's talk about concurrency of angle bisectors. So again, we start with a triangle. And what the concurrency of angle bisector is you bisect each angle. And that point where all three of those bisects meet is the point of concurrency. So since these are bisected, each of the angles are going to be the same as the other angle that was bisected. And that point that's created by that concurrency is called the incenter. And one more thing you can do with this is if you bisected each of those sides of the triangle, they would all form a 90-degree angle, and they all would be the same length. So these all would be the same length based on the concurrency of angle bisectors theorem. And like on the previous one, we can also do a circle on this one, but here the circle would be on the inside because all three of those bisectors for the sides are equal distance, so the circle would be on the inside. That's why the point of concurrency for angle bisectors is called the incenter, because it's inside, it's the center of the circle that's inscribed inside the triangle. Alright, so now I labeled my triangle and my bisectors there, A, B, C, D, E, F, G. And I'm telling you GD equals 2x plus 8 and BG equals 5x minus 1. So we need to find those lengths of GD and BG. Well, if you remember what I told you, those side bisectors are the same length. So we can set GD equal to BG. So we can say 2x plus 8 equals 5x minus 1. And then just solve them from there. Subtract 2x from both sides. We get 8 equals 3x minus 1. Add 1 to both sides. We get 9 equals 3x. We divide by 3. We get x equals 3. Now we're not finished. We've got to put that into one of those equations to figure out the length. So if we do 2 times 3, oh, that's not a 3. We're substituting. 2 times 3 plus 8. 2 times 3 is 6 plus 8 equals 14. So both GD and BG would equal 14 units. That would be the same thing for FG. FG would also equal 14 units.